In this lecture, let us learn about the resistors in series. Two or more resistors are said to be in series combination if they are connected end to end such that, and applying potential difference, the same current flows through all the resistors. Which is the most important statement you have to remember in your mind. That is, when we apply the potential difference, the current which is flowing through the entire circuit, which is same, that is equivalent to I. Okay. Let's see the construction how it is exactly done. Okay, consider R1, R2 and R3. Three registers R1, R2 and R3, place them in series combination. Okay, then V with the potential difference across this combination, and I be the current through the circuit. That means I told you initially while discussing this statement, the current which is passing through the entire circuit is same, which is got from this applied potential. Okay. After that, if V1, V2, V3 are the three potential differences across the resistors R1, R2 and R3 respectively, then according to Ohm's law, I think you people might have heard about the Ohm's law, and you people are know about the Ohm's law, that is V is equal to I into R. Over here, the current across the entire combination is same, but the resistors value is different, that is R1, R2 and R3 with respect to V1, V2 and V3. Okay, keep that thing in your mind. And we know that according to Ohm's law, V1 is equal to I into R1, V2 is equal to I into R2, V3 is equal to I into R3. And we know that the potential difference, the total potential difference across this combination is equal to the sum of the potential difference across the resistor 1, resistor 2 and resistor 3. That is V1, V2 and V3. Okay. V is equal to V1 plus V2 plus V3. Substituting that V1, V2, V3 value in this particular equation, we get the equation number 1. Okay. Mark it as equation number 1. After that, now, let us consider an equivalent circuit through a single resistance which produces the net effect of three resistance R1, R2 and R3 in series. Let us consider a equivalent resistance which has capacity of R1, R2 and R3 within it. Okay. This is the equivalent resistor which has a capacity of R1, R2 and R3. Okay. By applying Ohm's law to equivalent circuit we have, V is equal to I into Rs. Call this as equation number 2. Okay. Equation number 1, what we have, V is equal to I into R1 plus I into R2 plus I into R3. Right? Okay. Take I as common from here, and when we compare these we get cancelled because they are same. Okay, after that we'll compare this with this I into Rs, which is equal to I into R1 plus R2 plus R3, right? And IA also get cancels. This I also get cancelled. Then we left out with Rs is equal to R1 plus R2 plus R3. This is the derived equation which we want for resistors in series. Thus, the equivalent resistance of number of resistors in the series is equal to the sum of individual resistance. That means there may be number of resistors connected in series. The equivalent resistance Rs is equal to sum of the individual resistance, that is R1 plus R2 plus R3 up to Rn. Okay, that is the thing. That's all for today. Let us learn about the resistors in parallel in next class. Thanks for watching. Happy learning.